All right, I said I would go over question 7 to 5.5, and then somebody asked to see question 4 to 5.6. So those two questions are going to be in this video. The first one here on question 7, they're telling me that U and V are both 25. Of course, my tablet doesn't want to work. There we go. All right. So this is 25. 25. W is 34. I think the most common way of addressing this is people are going to try to find that angle first. And so what they do is they go sine of 30 over 25 is equal to, now we don't know this angle, so they just say sine of D over 34. Cross multiply, I get 34 sine of 30 is equal to 25 sine D. So I would divide both sides by 25. And I'm going to inverse sine both sides so that I can get D. All right. And I don't think there's an issue with people trying to do that and figuring that out. But what is an issue is what is yielded from that. So if I go second sine 34 sine of 30 divided by 25, it gives me that angle there. Okay, so I make the assumption that that's 42.84. But then when I want to find this angle here, because I need to work in here, because I think the first question is to find that angle, I work in here and I say, okay, well that's got to be the supplement, so I subtract that from 180, and I get 137. So I assume that this is 137, but if that's 137, then because this is the isosceles triangle with U and V, then that has to be 137, and those two angles together violate some of our geometry of the triangle angle sum theorem. So this, you just start thinking, well, this doesn't work. Well, it doesn't work this way because if we look at this triangle here on the right that we started with, this is the ambiguous case. This is the side-side angle case. So 42.84 is an option, but that 42.84 isn't the option that is meant for this triangle. Okay, so remembering with the side-side angle, there could be two solutions. This triangle does not incorporate that solution. This triangle incorporates this to be the 137.15, which is the supplement of the first angle we found, and then that means this here has to be 42.84, and this here has to be 42.84. Okay. So then the next thing that they ask you for is what is BCD. So BCD is that top angle. Okay, so I misspoke when I said they wanted to find this angle. They actually want you to find this top angle here. So that's going to be the 42.84 times 2 subtracted from 180. And my sign's messed up, but it should give me that 94.3 that we're looking for here. Okay. The next thing they want to know is what is angle DCA. Well, I've already got the 137.15. We got the 30. Let's remove that from 180. Sign's going to be messed up, but we get 12.85. 12.8. That's kind of how you would do question 7 out of 5.5. This question here out of 5.6, the last one, basically give you the rundown real quick. They tell you that the tower here is 1150 feet, 1,150 feet. They walk through and they say angle A, this red angle over here, is 65 degrees. This little blue angle here is, I think, 52. And then this angle here is theta, which is 45. The overall goal is to find the distance between the two buildings, or the two landmarks. I've gone ahead and made a quick GeoGebra for this to kind of give you a view of what they're trying to get at here. So this is the three-dimensional kind of rendering that they're trying to get us to view. And ultimately, they're asking us to find that orange segment down here at the bottom. If we look at this at the beginning, this height is right here is 1150. they work through and so angle A over here, this red angle, is actually that angle there between the tower and this red line of sight down to this building. The blue angle beta, or B, I guess, is from the top of the tower down to this first building. So it's that angle B that's blue that you can see. And the theta, which is one of the harder ones to see, I think, is if we were to look at it from this view, theta is now the angle that is between the red and the blue. So what we need to do to be able to find this yellow or this orange distance down here is we need the red distance and the blue distance. So we should be able to do that with some pretty fundamental SOHCAHTOA stuff. If I'm looking at that, just that blue triangle, or the triangle that incorporates the blue line of sight, that's a 90-degree angle there. This is 1150. They tell me B, this angle up here, is 52. We should be able to find, I'm just going to call it H for the hypotenuse. We should be able to find that. This is the adjacent side, that's the hypotenuse. We should be able to say cosine of 52 is equal to 1150 over H. So then H is going to be 1150 divided by cosine of 52. So that's going to be the blue distance. I should be able to do something pretty similar now for this red distance. That red distance, we have this triangle. Again, the height of the tower is 1150. The red angle is 65. And again, I want to use that as H. So I can say cosine of 65 is equal to 1150 over H. So then there, and let's call it H sub 1. H sub 1 is going to be 1150 over cosine of 65. So those are the two distances then for that red one and that blue one. So if we go ahead and evaluate those, see what they are. We've got 1150 divided by cosine of 52. That's the blue one. So it's 1867.909, and that makes sense based off of this vertical distance being 1150. That blue distance is going to be longer, but it's not ridiculous in regards to that size, so that's probably a good thing. Then we'll do the other one. So the 65 is the only thing that changes. So the red one is now 2721.1318. Okay, so that's great. It gives us all those values. So now we can look at this triangle that's kind of facing us here with this black theta in it, be this triangle there. If I look at that, we have all the components that we need. We have a 45-degree, so I'm just going to draw this this way. So this would be the red segment. We got the blue segment. And then, I don't know if I can get orange. Yeah. I would have this orange segment down here on the bottom that I'm trying to actually find. So I'm just call that X down there. The blue one we found to be, I believe that was it doesn't ultimately matter if I mess these up. Come on. Alright, so let's do that again. I apologize. When I get the 3D portion up, sometimes the tablet likes to freeze everything. And there, it just turned everything off. Alright, so we had the red segment, the blue segment, and then our orange segment. I said the orange one was x. Kind of picking these distances off of the calculator. The blue one, I believe, was the 1867.909 number. The red one was the 2721.13. Let's call it 2. And then this angle here in the middle was 45 degrees. So now I should be able to use the law of cosines to say that x squared should equal, this is side angle side, x squared should equal 272.132 squared plus 1867.909 squared minus 2. I'm going to reference that red, so that 272 number should go here, or sorry, 2,721 number should go there, the 1867 number should go here, and then cosine of 45. So if we type that in the calculator, let's kind of see what would happen here. Let's do this. Let's put that number, and I'm just going to hit STO X, and then I'm going to pick this number off. I'm going to hit STO, and we'll just call it A. All right, so what that's going to allow me to do is just type this a little bit quicker. I'm going to write x squared plus then a squared minus then 2 times x times a cosine of 45. That gives me that distance there. I will then take the square root of that. Gives me 1924. So let's see, 1925, they actually round to the nearest foot. So 1925 would be the answer. Hopefully that's helpful. We can talk about that in class if you end up having questions in class as well.